Welcome back, and we are continuing our discussion of networking basics, and we want to focus now more in the area of communications protocols. And our next subject area will be the common network protocols that are in use today, the most important ones, as well as an introduction to how the Internet is managed and supervised for the benefit of the public and businesses and the world at large. At the center of this, of course, is the TCP/IP reference model, which is a suite of more than 50 protocols. It's often called the TCP/IP stack, and it was developed over a long period of time when they were first getting the internet started, and we had scientists and engineers learning how to set up standards and rules for communications between companies and between institutions like universities in particular, so that we could in essence create an internet like we have today. And the TCP/IP reference model that we're going to look at in some detail maps directly to the OSI reference model that we've been talking about by layers. And you'll see that they really overlap each other, and this is the way in which these engineers and scientists have put these things together for us so that everything cooperates and works together so that we can send our email and do all of the things that we do with the internet today. The first thing we need to come to grips with and understanding is the IAB, which is the Internet Architecture Board. It comprises 13 members, and six of these 13 members are selected by the IETF, which is the Internet Engineering Task Force. The functions of the IAB, though, are the following. It is to determine the future of internet addressing, because we have to have addresses to get everything to communicate. Then also the architecture of the internet itself and the direction of the IETF, which is in particular, the IETF manages the top-level domain name system. The following that I'm going to mention is a list of subcommittees of the IAB, the Internet Architecture Board, and their functions. The IESG is the Internet Engineering Steering Group, and it works on Internet standards and also oversees the work of all of the other groups. Then you have, of course, the IETF, the Internet Engineering Task Force, is an open international community, committee of network designers, vendors, and researchers. So you'll find, someone maybe from a large company like Microsoft is on this board, as well as perhaps someone who's working in universities doing extensive research on how to improve networks and design them and improve devices and so forth for communications purposes. The IETF is divided into subgroups, which are organized based on their area of expertise, such as routing, or transport. Then there is the IRTF, which is the Internet Research Task Force, and it is designed and put together to promote long and short-term research related to Internet protocols such as TCP/IP, IA, Internet Architecture, and IP version 6. IANA is the next subgroup, and IANA is the Internet Assigned Numbers Authority, and it works under the INIC. which is the Internet Network Information Center. Internet consists of Network Solutions, Inc. and AT&T Corp. The function of INEC is registration and education services. Internet manages registration of second-level domain names under the following top-level domains. That's .gov, .com, .net, .mil, and .org. So that's some way in which to look at the Internet and how it is managed and supervised by these different committees and different groups that come together to make decisions about managing it and making sure that it continues to be effective and useful in the public domain and with businesses and governments as well. Now the big thing to talk about is the TCP/IP reference model. And it essentially is made of 4 levels. When you can look at it in 2 different ways, actually. It depends on who you talk to. When you talk about the TCP and the IP together, you can essentially talk about 4 levels: the application level, the transport level, the internet level, and the network level. Well, those are all mapped essentially to the OSI model, but you can also go deeper than that. You can even find graphics that will show all 7 of the OSI layers and show how TCP/IP matches directly to the 7 layers. But we'll use this 4-level model for now, and it will simplify things for us and help us to talk very efficiently and effectively about this model and how it works. The application and presentation and session levels are in the top level, where we have the major applications that we use on a daily basis. And here it's about users and what they need so that they can be using the internet and doing things with it to accomplish their many tasks. So we'll go through some of these internet applications. And for example, we have SMTP, Simple Mail Transfer Protocol. We're going to talk about that. Then there's Telnet, which is also at this upper level here. File Transfer Protocol, which is FTP. And HTTP, we use that all the time when we type in a domain name or URL in our browser. And then we have the use of HTTP and also HTTPS, which is for secure. The little s stands for secure. And then SNMP, which is Simple Network Management Protocol. And then the domain name system itself, DNS. So let's talk about the first one, SMTP. It's used for electronic mail, email, like I said. And it transfers these messages between hosts. To send an email message, the sender types in the address of the recipient and a message. The electronic mail application will accept the message, the email, if the address is right, of course. It has to be correct. And deposit it in a storage area, a mailbox, if you will, that belongs to the recipient. The recipient then retrieves a message from his or her mailbox. You often did this maybe if you had AOL, you have Hotmail. This is what your mailbox is. It's Hotmail, it's Yahoo Mail or Gmail, any of those things. An email address, of course, is made up of the username at the mail server address. And you've probably seen many of them. Some of them can be quite complex, a little more complicated. For example, the one in the reading material shows a username as UPPAL, UPPAL, and then at SCUS1, which is the name of an actual workstation on campus at SCSU, which is located at CTSTATEU, and of course .edu tells you that it's an education center, a university. So when you look at some of these email addresses, they can be quite interesting. The more involved they are in actual location and geography of where that mail box actually is. Then there's something known as Telnet. Telnet is another name for remote login. Telnet is one of the most important internet applications we ever had. It enables one computer to establish a connection to another computer. And users can log in to a local computer and then remote log in across the network to any other host. This is great for administration and administrative purposes. The computer that established the connection is referred to as the local computer. The computer accepting the connection is referred to as the remote or host computer. The remote computer could be hardwired, could be a hardwired terminal or a computer in another country. Once connected, the commands typed in by the user are executed on the remote system. So there you go. That's why it's so powerful. The user sees on his or her monitor what is taking place on that remote computer. Remote login was developed for Berkeley Unix to work with Unix systems only, but it has been ported to other operating systems as well. Telnet uses the client-server model, and that is the local computer uses a Telnet client program to establish the actual connection. The remote or host computer runs the Telnet server version to accept this connection and sends responses to the request. If you ever saw the movie with Sandra Bullock in it called The Net, toward the end of the movie when she was trying to get away from the bad guys, she used Telnet on a computer at a computer show to log into a computer at the company that was surreptitiously planting the Trojan horses onto systems around the country. So you can find a real use of it even in Hollywood. FTP is File Transfer Protocol. It allows the internet users to transfer files from remote computers without having to log into them. FTP will establish a connection to a specified remote computer using a remote host address, an FTP remote host address. Once connected, the remote host will ask the user for identification and password. Upon compliance, the user can download or upload files. Some sites make files available to the public. To access these files, users can enter anonymous or guess for identification and use his or her internet address as a password. This application is called Anonymous FTP. FTP is great when you have large files to transfer, or perhaps you're working with a company like a law firm which may need to transfer large amounts of files, information, data on a case, and they need to, say, compress those files and put them in a form to where they can be transferred quickly to another office. HTTP is the one that you see the most because if you're surfing on the internet, you're using HTTP all the time. It's an advanced file retrieval program that can access distributed and linked documents on the web. Messages in HTTP are divided into request and response categories and work on the client-server principle. So the request command is sent from the client to the server. The response command is sent from the server to the client. HTTP is a stateless protocol that treats each transaction independently. A connection is established between a client and a server for each transaction and is terminated as soon as that transaction is complete. There's also HTTPS, which is a secure connection using the HTTP protocol. We've got SNMP, Simple Network Management Protocol, is used by the network administrator to detect problems in the network, and this is especially with the routers and the gateways. SNMP provide information for monitoring and controlling, managing that network. SNMP is divided into two parts: the management system and the SNMP agent. The management system uses a command to the SNMP agent, and the SNMP agent responds to that command. And SNMP management system can manage network devices remotely, and that's why it's a cool thing for network administrators to have as a protocol to use. The domain name system is a unique name that it's a domain name that is a unique name used to identify and locate computers that are actually connected to the internet. This might be something like www.microsoft.com. DNS is a collection of databases containing information about domain names and corresponding IP addresses associated with them. The top-level domain names can be categorized. You'll see a chart in your reading material that shows the root server, and then you see all of the domain categories that we can have, like .com, .edu, .net, .gov, .org, .int, .mil, .jp for Japan, .uk for the United Kingdom, and .ca. I think that might be Canada. And you'll find that you can have further sub-level domains under each one of these top-level domains. There was a time when there were 14 root servers across the world, but now there are probably much more than just these. You'll notice that these top-level domains refer to different kinds of sites. EDU is educational, as you know. GOV is a government site. COM is a commercial site, a business site. MIL is military sites, ORG are organizations, usually not nonprofit. And INT are international organization sites. You can have country sites, as I mentioned, like .UK for United Kingdom and FR for France. So that gives us a way to start into the TCP/IP reference model. We'll continue this discussion with common LAN network protocols and common WAN protocols in the next lecture. Talk to you again soon.